Okay, so if you haven't finished lesson 7 yet, spend some time finishing up lesson 7. There were a couple of the last pages with some challenges that you needed to do. Okay, but there's plenty of people that are eager to start working on the sprite properties. Okay, we're going to look at sprite properties and look at adding some text before we do our first sort of test grade with this, where we start creating like a mini scene, okay, where we have kind of like a little bit of a comic. So sprites, we can do different things with them. We can take those images, and we have code now that we can change the rotation. We can spin things left, we can spin things right. We can change how big it appears, whether it's small or large. And I can change its X and Y locations. Okay? So all of this after the dot is known as a property. Okay? We use dot notation so that we can change a specific property for the specific sprite that we name. So going on to page 2. It says, look at the code below and predict where the B sprite will appear. Well, we have a sprite that's created that we named B that appears first off middle of the screen, theoretically. And we set the animation to a B. Okay, the actual picture of one. Then it sets an X and a Y for this B. Well, the new X is 350, the new Y is 350. I would expect that we have one B that shows up in the bottom right-hand corner. Why do I think there's only one B? Because we only have a variable or a sprite called B. But it set properties like what is the picture for it, and what's its X location, and what's its Y location. So when I run it, there's a B. Imagine that.
Wow, so amazing.
Okay, so sprite properties keep track of all the different information that your program needs to know about a sprite. Okay, such as the size and the location. And we can also set these as different variables. It says run the program to see where the sprites appear. Change the X and Y so that the properties of the paintbrush sprite move it to the palette. So right now, the palette is set to 100, 300, and the brush is set to 300, 100. So the brush is way away from the palette. How can I get this brush to be touching the palette?
My thing
Okay.
is not clicking.
Your thing is not clicking? Have you tried to refresh? The reason, okay, so you tried to select here. So you needed to select one of these. You don't need to move anything here. All you do is say one. So this is the one we're at right now. We need to move this to here. Okay? So we're not changing anything about the palette. How can we change the X and Y of the paintbrush so that it touches the palette? So how can I change the X and the Y there? What would the new X be so it would touch the palette?
Not 100.
We could definitely try 100. And what would you put for the Y? We could say 300. We could just switch it so it has the same X and Y as the palette, right? Now, is that going to show behind the palette, or is it going to show on top of the palette? Why? Because it's lower in the code. It gets drawn after the palette. So if I reset and run, you'll see that they would actually be on top of each other. What if I just wanted to touch the red? What would I need to put? Maybe I could try 120. We can give it a try. And let's make it a little higher. Got 280?
Yeah.
And we're closer. I think we need to almost add that much again. Let's try 140 and 260. There, we got it touching the red. Okay, questions on page 3? Pretty simple. Okay, how about 4? It says new properties. So here they're going to show us how to use rotation and scale. It says check with the 2 new blocks in this activity. Okay, that's this right here. There's sprite.scale and sprite.rotation. Okay, this is going to make these drums and notes different. So we're going to run it. Okay. Now if we look, they have changed the scale and the rotation of note 1. They have changed the scale and the rotation of note 2. And then note 3 and note 4 are just basic. So if I look at this, this was the original sprite, which was note 4. Note 3 is also the original sprite. But 1 and 2 are a little bit different. You notice that 1 is tilted back a little bit, 1's tilted forward a little bit, and they're different sizes. Okay, scale is always going to be like 1, scale equals 1 or 1.0 is like the original scale. So if I set it to like scale equals 0.5, that's saying make it half as big, only make it half the size. If I said scale equals 1.5, it would be like that big and half as much again. If I set it to scale equals 10, that picture becomes 10 times as big. Okay, so it's just kind of like a multiplication factor. As far as rotation, think of degrees. Okay, that at the top, this is 0. And I would turn it, whether it is positive, meaning to the left, or negative, which is turning to the right, I think. Let me check. So right now, note 1, this is positive to the right, negative to the left. So this is negative 30. This note is negative 30. And this one was positive 20. So all this does is it says how much we want to turn it around. I can go either direction, positive or negative, and this changes the size. It says use the rotation and scale blocks in the last 2 notes and make those last 2 notes also look different. So I'm going to come to note 3, add in a scale and a rotation, and to note 4, add a scale and a rotation. What else do I need to do? Can I just leave it as sprite? Note 3, can I leave this as sprite? No, I need to put in note 3. And here, note 3. For note 4, I need to change the sprite to note 4. And now I need to put some values in. So maybe I want to make one 10 times as big. And I want to have it upside down. because I still have empty parameters, it won't let me. That makes sense. Let's make this only 3 times as big, and I'm gonna rotate it by 90. Well, I can't really see much now, can I? I made that one a little too big. Let's try making this only 3 times as big. Still kind of crazy. They're too big to even see. Looking better. Let's change the scale on this one to that one still covers that other one up. It's there, but it's kind of hard to see. I can see it underneath that this one was turned upside down and is smaller, and this one's much larger. Maybe I'll just change that to 0.75 so I can actually see everything. You can try to put some crazy values in, but sometimes you're like, nah, this still isn't really working. And so now all these notes are in all different rotations, different sizes. Any questions on how to add in the scale and rotation for note 3 and note 4? You'll find that, you know, the scale, you probably don't want to try to make it too big, otherwise it fills the whole screen. Rotation, you can rotate anything up to like 360 degrees. Obviously, you pretty much go like up to 180 positive, up to 180 negative. You know, doing it more than that doesn't necessarily make sense if you're just setting an initial rotation. But as we start to change things, as we add in ways to have continuous movement, you'll find that we're going to add or subtract values that will actually continually make things just spin all the way across the screen. Any more assistance needed on this one? Just make sure that you have scale, rotation, scale, rotation. Now, why do I have a yellow here? It says a leading decimal point can be confused with a dot. They're saying, hey, this would be really much better. Although we can still read your code, it would be better if it was 0.2 and 0.75 so people don't get confused with that. And I got rid of the yellows. It just gives you tips to make things better, more readable, more usable. I'm going to click on finish. So we're going to make use of scale so that these animals can be the right size. The scale property changes the scale of the sprite. 1 is normal size. 2 is twice as big. 0.5 is half as big. Use the scale property to make it look just like this picture. Make sure that each animal is as big as it should be, and make sure that the fish fits in the pond. So there's a fly, a fish that goes into this pond, this cow, and this elephant. So right now, this cow is entirely too big. Okay, and this is the initial scale of this is all the normal sizes. We definitely need to scale this cow down. Let's try to bring that down to maybe 0.5. So looking closer, I feel like the elephant is still a little bit big. Maybe. I was 0 point reset run. Oh, I think actually Texas was exactly right. So I said that this is 0.75, 0.75. Cow at say 0.5. I'm gonna put my 0 in. Fish,
0.4.
0.4. 0.4.
I put 0.3, and that was good.
If I were to try to match up what they have, I would say it would need to be a little bit bigger.
0.5.
Like, I would still accept 0.4, but sometimes you just feel like being a perfectionist. Oops. I wanna keep playing. Still running this one. That looks like a better match with the fish pond here. That fly though, that fish is gonna have a hard time catching that fly. What kind of scale do you think we should have for that?
I did 0.4.
The 0.5 for that? That is looking like it's matching up pretty well.
That's better.
I think you guys picked some good scale. Okay, so we're gonna finish up. So we picked 0.4, 0.5, 0.5, and 0.75. Ended up being a really good scale. So let's look at rotating. So we need to rotate these cars so they all fit into the traffic lane. Now, our cars need to be on the right-hand side of the road. We are in North America. So, you know, it says rotation, rotates the image between 0 to 360. The image is rotated clockwise. So this is positive goes clockwise. Negative is counterclockwise or anti-clockwise. So 90 would take something that's straight up and down and turn it 1/4 turn to the right. We need to add the dot note rotation blocks to the code to make all the cars look like they're traveling the correct way. So for each of these cars, we're going to need a sprite rotation. So I'm adding that to the bottom of each of these areas for the cars. I need to change the sprite names. Here we have car, capital T for top. Oh, I think I missed one. Here we need car, capital L for left. Car, capital B for bottom. And that's how, so I ended up somehow with 2 down here. Car right. So if we look at the rotation, the top one actually looks okay. I'm gonna leave it as car rotation equals 0, saying I think it's going the right way. Or is it? Depends on your point of view, I guess. What's your question, Gabe? Yep, definitely. If you need to unplug the other thing, actually there's also, I think, a power bar right behind you. Is that one plugged into the wall? I'd use that. I debate whether or not that one is the right way or not. I'm tempted to try 180 just to see what happens. Because I don't know if we're looking at the front or the back of the green car. You know what I mean?
We're looking at the back because if you look closer, like you can see the lights, and in the picture you can see the lights, and then it's facing the right direction.
Oops. So yeah, we're seeing the back of the car, which is what we wanted. So that first one, car rotation is 0. Would be correct for the top one. We don't need to rotate it, but why would I put in car rotation equals 0 anyways? Do I have to? No. I'm leaving room for some variations, some changes by setting this up as a possible property for it, even though we don't need it right now. Okay, and I'm keeping it the same as the other things. How much would you rotate the one on the left? It needs to go from pointing up to pointing to the right. What do I put in here to do that? 90. So if I reset and run, now that's going the right way. How about the bottom one, the blue one? That one I need to turn 180 because we don't want it to be crashing into the other vehicles. If I reset and run, now it's driving this way. They're both driving on the right hand side of the road. The only one that isn't driving on the right hand side of the road is this yellow one. What kind of rotation should I give that one? 100? Why do you say 100? If I try that, I think it's going to be too much because 90 moved it facing right. I feel like it's going to run off the road. See? Now it's going the wrong way. I think it's going to be less than 90. What? 45?
Yeah.
I think that's probably pretty close. That is looking quite nice. Okay, so this one we didn't have to rotate. This rotation was 0. This one was 90. This one was 180, and this one's 45. Okay, so now we need to make all the food fit on the plate. So we need to make use of the sprite properties to scale them to fit on the plate. Right now, here's what we have. And it looks like they want us to fit it like this. So we have to scale these down. So I'm going to come to my sprite menu. And it looks that way. So I'm going to put a sprite scale underneath fries, sprite scale underneath the burger, and a sprite scale underneath the dessert, the watermelon. So I need to have the names: fries, burger, and dessert. What do you think? Burger maybe half the size?
I think all of them.
Do you think maybe all of them are half size? So it goes 0.5, 0.5, 0.5. See if it matches.
No.
That seems a little too small. I think we're close.
Maybe 8.
You think 0.8?
Yes. No, too big.
No, it turns out too big. 0.6.
3.6.
Reset, run. That looks like a match, doesn't it? It looks to be the same distance as what they had already set up in theirs.
On the dessert,
Mm-hmm.
and the destination, oh, I see something. I messed something up.
You messed something up? Yeah, sometimes when we go to delete something, we delete something else by accident. When you do that, you can do Control Z.
Oh, I forgot.
Yeah, I forget about it too. Sometimes you kind of get stressed. You're like, oh, where'd that go? And you don't want to restore it like the old version because you made too many changes. Control Z. Control Z. Takes you back a step.
Your friend.
Control Z is your undo. Man, this is pretty easy. So now I want you guys to do this. And I'm pretty sure in like the 20 minutes you have left, you should be able to finish this up. And if you haven't finished lesson 7, go back and finish that up.